So hopefully, right, so power of quotient, AB to the third power, is multiplied by itself 3 times. So your numerators multiply A to the third, denominators multiply B to the third. So really all it's saying is you can just take that third and apply it to the top and to the bottom separately like that. That one's pretty straightforward. And then the quotient rule is really just another variation of this multiplication rule, which I think we talked about earlier. Right? We talked about this one previously. So like say we have x to the 6th over x to the 2nd. This is really 6 x's being multiplied. X squared is 2 x's being multiplied. And remember, x over x is just another form of 1. So that makes 1, that's another 1, and you're left with 4 x's on top, x to the 4th, which again is x to the 6 minus 2. I'll make that 4 a little higher. All right, so those are the first 4 rules, which I feel like we've gone over some of these before. Still, it's good to with them. I'm nervous about this not working out. Okay. Good. Power to power, you multiply. I think everybody's good with those ones so far. Now we're going to look at the zero exponent rule. Okay, so this one I've talked to you folks about previously. We'll review it now. The first one is, remember, x squared means multiplication, you always start with what? Addition, you always start with 0. Multiplication, you always start with 1. Yep, because anything multiplied by itself is just 1. That's our identity. So you start with 1, you multiply by x twice, 2 x's. X to the 1 power, you take 1 and you multiply by how many x's? 1. Just 1. X to the 0, you start with 1, you multiply by no x's whatsoever. It's just, leave it alone. X to the negative 1, you take 1 and instead of multiplying, you do the opposite, right? It's negative. So then you what? Divide, exactly. Divide by x. And x to the negative 2, you take 1 and divide by x twice. Right? Good? So what this is saying, the zero exponent rule, is just saying that any number to the 0 power is 1. Good? In other words, we take 1 and we multiply by no b's at all. Power of a product. Aha. So this one I feel like folks sort of accept pretty well. Power of a product. That's this one here. If I have a, b to the 3rd power, it's the same thing as ab 3 times, right? ab times ab times ab. And all together I have how many a's being multiplied? 3 of them. How many b's being multiplied? 3 of them. So you can just take that 3 automatically and just pop it by each one of those individually. I just go, 3, a to the 3rd, b to the 3rd. And then we have negative exponent rules, which I just did kind of right here in purple. So that's also right here as well. Right. What you'll also notice is, please notice also that if I have if I have 1 over x to the negative 3, you can just, to get rid of that, to get rid of that negative exponent, you can just pop it to the other side. It becomes x to the positive 3 over 1. So anytime you have a negative exponent, you can just hop it to the opposite side. If it's on the bottom, move it to the top. If it's on the top, move it to the bottom, and change the sign of the exponent. So that's actually huge. That's really big. So here, for example, we have down here, we have a to the negative n, b to the negative m. Well, I'll give you real numbers. Let's put real numbers in there. Negative 3, b to the negative 2. It's the same thing as moving it to the opposite side. So I see a negative exponent on top. I put it to the bottom. Now the exponent is positive. B to the negative 2, move to the other side. So then my negative 2 becomes positive 2. So that's hugely helpful. And we'll use that a fair amount. So those are kind of the super useful, important ones to know also. So good, I'm glad the camera's working for that part. All right. So let's apply some of these. Has everyone taken notes on this and they feel like they've got the handle of this? Okay. If not, take pictures of these or look them up on Canvas. Yeah. Okay. All right. Here we go. So now all we're doing, oh, right, here's the other part. Okay, so what does a rational mean? Let's talk about this a little bit. So the cube root of x really means x to the 1/3 power. What it means is what number multiplied by itself 3 times gives me x. So if I had this multiplied by itself 3 times, I would get x. That's what that means. You can also write this as, I'll give the in-between step. So they all have the same root. I can write them all together. X times x times x. So what this means is, what number multiplied by itself 3 times gives me x. So here, x to the 1/3 multiplied by itself. I need a better third than that, sorry. Let me change this. Hard to get good 3's in here. X to the 1/3 multiplied by itself 3 times. What's up with multiplying exponents with the same base? You add their exponents, correct? So this becomes x to the 1/3 plus 1/3 plus 1/3. What's 1/3 plus 1/3 plus 1/3?
1.
1. 1/3 plus 1/3 plus 1/3. X to the 1. So that's just x. So this is all I'm trying to prove to you, folks, is that whatever is here, that's the 1/3 root. So it means x to the 1/3. Okay, so this is where it gets interesting and important. The number, Shania, the number that's in here is the number on the denominator of my exponent. So the number in here is on the bottom part of the exponent. I'm sorry, of the yeah. So now we're talking about fractions of the exponents. The number that is on top here would be the number that goes on top here. So for example, if I had this, I'd write this as x to the bottom part is a 3. The top part would be the 5. Likewise, if I went the other way around, what would that be? So this 2 means 2 there, x to the what inside? So let's just be more specific about this. So this part goes on the bottom, this part goes on the top. This part, the bottom part goes in here, this part goes right in there. X to the 3rd. Everybody all right with this part? So all this stuff we're doing here is all just practicing rewriting them. We're not simplifying them. Do not simplify. See, it says do not simplify? That means do not simplify. Just means rewrite this. This is 3 to the what? 1/2. This is, what's this next one? Negative in front, 3 to the what? 1/2. Can people see the difference between those two? This is on the outside, so it stays on the outside. Okay, outside. Oh, that's not dark enough. Okay. So everybody do the next one, C. Do the next one. 3 to the what? Okay, check with the neighbors. I'm going to call on somebody randomly in 15 seconds. Who are not talking, I'm more likely to call on. Yes. Did you just come in? I gave it to you. If you didn't hand her the first sheet?
I didn't even enter the last two, so I don't know what to do with the next one.
Okay, so check in your neighbors. I'm going to randomly call on somebody in 15 seconds to give me the answer to this first one. Now you got it? Jenna, you got this? Okay, so it's a square root, so it should be 3 to the what? Just the square root part of it. 3 to the what? 1/3, 1/2, 1/4, what? 1/2. But it's on the bottom. So
You flip it?
so it becomes, so the exponent is positive or negative. Okay, so let's do this part. We'll do it in steps. 1/3 to the 1/2. Everybody go with that part? Yes? No? So does everyone understand? Square root 3 is 3 to the 1/2.
No, I don't get the first two, so I can.
Okay. Need a little bit more review. Okay. Square root of 3 means what? You need to multiply something by itself twice to get 3. Is everyone understanding that?
Okay.
That's the same thing as 3 to the 1/2 times 3 to the 1/2.
Why is it the same thing?
Because what's 3 to the 1/2 times 3 to the 1/2? 3 to the 1/2 plus 1/2? 3. 3 to the 1/2 means you have to multiply it by itself to get 3. So square root is the same thing as raising something to the 1/2 power. Because both of them say, whatever that is, you have to multiply it by itself to get 3. So for example, what's the square root of 4? Anybody? What's the square root of 4?
2.
2. What is 4 to the 1/2 power? 2. What number do I need to multiply by itself twice to get 4? They're the same thing. Everybody pull out your calculator. I think it's on. Is it on? It's on. Oh yeah. Okay, and I'm going to do 4 raised to the 1/2 power. 1/2. Leave it like that. Does everyone see how it's 4 raised to the 1/2 power? Yes? No? Everyone look up. Is that 4 to the 1/2 power? Everyone good with that? Okay. Equals 2. Anything raised to the 1/2 power. Oh, what's 1/2 anyways? 1/2 is the same thing as 0.5. Right, so 4 raised to the 0.5 power. 2. What's another one? Square root of 9. 9 raised to the 0.5 power. 3. Everybody, okay, this is making sense for you. What's another one you know the square root of? What's the square root of 25?
5.
5. 25 raised to the 1/2 power. 5.
Anything
So
with square root is at half.
So the square root is the same as raising it to the 1/2 power. Because for the very reason that as we define them, right, this means you have to multiply by itself, this by itself twice to get what's inside. So 3 to the 1/2 times 3 to the 1/2, we said that's 3 to the 1/2 plus 1/2, 3. So when you multiply 3 to the 1/2 twice, you get 3. You get 3 to the 1. So that's why they're the same thing. Just one is, this is radical notation. This one is exponent notation. But they're the same thing. So cube root of 3, square root of 3 is equal to 3 to the 1/2 power. Good? So how you get back and forth between them is take the number on the inside. What's the number on the inside, that little crook? It's hidden, it's an invisible 2. That goes on the bottom. What goes on top? It's 3 to the 1, so it's 1/2. So we have this invisible 2 here. And there's an invisible 1 there. So the invisible 1, that goes on top. This number here, that goes on the bottom, the denominator, always. Okay, so now we're here. We're at this spot. Is everybody with me? And are we all on the same frame of mind with this part here?
Mm-hmm.
Does everyone understand how I got from 1 over square root of 3 to 1 over 3 to the 1/2?
Mm-hmm.
Now, I want my exponent not on the bottom. 3 to the 1/2 on the bottom means what? 3 to the negative 1/2 on top. Yes, no? Remember, if it's on the bottom, I can move it to the top and just make the exponent negative. Well, or we just kind of know this, right? Because remember, we talked about this before, how x to the 1 over x is x to the negative 1, right? Remember we discussed this before? Yes, no? Okay. So I can just move it to the top, and it's a negative exponent, because I'm dividing by. Oh, we'll leave that maybe. Well, yeah, probably.
So that ends up, just 3 negative 1/2.
3 to the negative 1/2.
Okay.
Because I'm dividing by 3 to the 1/2, so instead it's 3 to the negative 1/2. Yeah, that's gone. All right. So how about this next one? Square root of x. How would I write that in terms of exponents? X to the what power? Everybody write that down. Write it in. Let me see it. What do you have? Oh, this one. This one. Oh, yeah. Do the next one when you're done with that one. Do the next one over. This is x to the what? Square root. Not x squared. Yep. Yep, and then do the next one. So the first one is x to the, there's an invisible 2 there, it's x to the 1/2. Sorry. What's the next one? Cube root of x is the same thing as x to the what? Does everyone have this one down? Is everyone written down the middle one? Jenna, what'd you get?
I don't know.
Okay, I want to check with the neighbors. Check it with your neighbors. Ryan, stay there. Turn around. Now you got it?
Oh, which one?
The E, this one right here?
Yeah, I got it.
If you're done with E, do F. Everybody do E and F, and then we'll come back and go over this. All right, we'll take a look at E. Again, remember, whatever is here, that goes on the bottom, the denominator. So it means on the bottom is 3. What's on the top? Yeah, this is x to the 1, so 1. Okay, next one. Does anyone try this one? Everyone try this one. Okay, so what's the number inside this little tiny crook here? There's an invisible what? 2. So it means there's really a 2 on the bottom. And then what's on top?
3.
3. Okay, good. All right, so let's do G. X to the what? X to the what? So you folks are finding this stuff here. I'm going to give everybody 2 minutes, and then we'll go over these. Look at these. This next one, 2 is on top, 3 is on the bottom. All right, so that one's 2/3. I'm going to erase these. Okay, next one. Okay, so this is there's an invisible 2 here. Everybody agree with me? Does everyone remember that little invisible 2 that's inside of here? I'm going to put them all inside the little spots where they belong. So it's 2 on the bottom, 3 on the top, right, because there's 3 here. But because it jumped from the bottom, the x was on the bottom, this is negative. Everybody all right at that part? If you want, I can do the in-between step. I'm going to do the in-between step. So it's 1 over x to the 3 over 2.
And then you split it.
Yeah. 3 over 2. And then we need to move it to the top. So that becomes x to the negative 3 over 2. Okay, the next one. This is the exponent. There's no exponent here, so it's an invisible 1 on top. To the regular square root is just 1/2 to the 1/2 power. Here, square root, so it's to the 1/2 power, but it's raised to the 5th, so it's 5 on top, 2 on the bottom. So up here it's 4 on top, 3 on the bottom. Right, because there's that 3 in there. Okay.
So is this, can you go back to J?
J, yep. You have 2.5, that's the same thing. 5 halves is the same thing as 5 halves is the same thing as 2.5.
Oh.
Yep. Okay. Now, we're doing the opposite. We're converting from rational to radical. So this means that that's going to be a little 3 inside of that crook there. 64. Is everyone sort of following that? Okay, yes, yes, no? This one's a little bit trickier. It's to the negative 1/3, which means it's on the bottom. So it's going to be 1 over my radical. What's my radical? What goes inside? 64. Raised to the 1 power. And then what goes inside my little crook? 3. That's a weird arrow by the solid. This one's also weird. So maybe I simplify this first. Negative exponent on the bottom would be I'm going to flip it to the other side and make it a positive exponent. 64 to the 1/3. So everybody write that as a radical. Everybody write that as a radical. 64 to the 1/3. Radical meaning this. Figure out where the pieces go. What goes inside? What goes in the crook? Find those spots there. Check with your neighbors, see if they have the same thing you have. David. So did anybody do it this way, where they did 9 over 100 inside? And they did the 2 on the outside, and then they did the 3 on the inside.
Maybe smaller.
Let me do this. So did anybody do it this way? 9 over 100 on the inside, and it's a 2, so put the 2 there, but you can leave it off if you want, since it's understood. And then a 3 here. Anybody do it that way?
I did, but I didn't put the brackets, so you need the brackets?
Yes, because if you don't have the brackets, then only the 9 is to the third power, not the 100. Do you know what I'm saying? Or you could have done it this way. You could have done it this way. Sorry. 9 to the third over 100 to the third, without the brackets. You could do it that way too. Right? You could do it that way. Or you could also do it this way. Square root of 9 to the third over square root of 100 to the third. Any one of those is fine. All right, we'll do one last one. We'll do E together. So the negative. So I think you should rewrite this as a fraction to the positive 3/2 first. So do that first, and then do the bottom part. 9 over 100 to the negative 3/2 is the same thing as what to the positive 3/2? And then write your part here. So what is it? Remember, if it's a negative exponent, what's on top goes on the bottom, what's on the bottom goes on top. So if I have a negative exponent, I can change it to positive exponent by putting the 9 on the bottom, the 100 on the top. Now just write it in like you did these previous ones. So you could do any one of these options. All right. Okay. Have a good couple days. I will see you folks on Friday. So you should have gotten one of these. Any one of them is fine.
What about C?
C, I'm sorry. C would be 64 on the inside and 3 on the outside.
Camera's still on.
What did we do today? We did,
Radical exponents, the domain of radical functions, and radical functions and their derivatives.
The camera's still on.
radical functions, domain, yeah.
Thank you.
Oh, yeah, you're welcome. Bye, take care. Hi.
You still want me to meet you here, right?
Yes.
From Pearson.
I'm sorry.
Anakita from Pearson?
Oh, right. Yeah, I'm so sorry.
And I
Yes.
sent you a reminder today.
Yes. I'm so sorry. I'm sort of a little bit, yes.
No, finish up and he has a question, I think.
Question? Go ahead.
The camera's still on.
Oh, thank you so much. Thank you. Appreciate that.